when finding relative extrema, in terms of like a relative maximum or relative minimum, the first step is to do the first derivative of a function given to you. So sometimes they might try to trick you and they might give you the first derivative already. So you need to be very, very careful. In this case, they give us the function, right? So what we need to do is to do the first derivative. So we're just going to use the power rule and we're going to do the first derivative here. And we're going to get f prime of x is equal to 12x squared plus 12x. And the derivative constant is 0, so that's 0. So the next step is to set the first derivative equal to 0, which is exactly what we're going to do right now. Now the next step is to solve for the zeros. So you can do this by factoring out a 12x and getting an x plus 1 and a 12x. So now I know that my zeros are x equals 0 and x equals negative 1. So the next step is to create a number line using these zeros, right? So what we're going to do is we're going to go over here and we're going to put negative 1 and 0. Now what we have to do is we have to find whether the values in between these intervals are positive or negative. So that's what we're going to do right now. We're going to do this by plugging in, by starting with a point smaller than negative 1. So I'm going to do negative 2 because it seems pretty simple to do. So we're going to plug it into this equation right here. So it's going to look something like this. 12 times negative 2 squared plus 12 times negative 2. That's going to give you 48 minus 24, which equals 24, which is positive. So the values before negative 1 are positive. Now I'm going to do a value after 0. So I'm going to do a 1. So if I plug in a 1, I'm just going to get a positive number. So I'm going to get 24, which is also positive. So now I need to plug in a number in between negative 1 and 0. So I'm going to do negative 1/2, and let's get it done. So we're going to do 12 times negative 1/2 squared plus 12 times negative 1/2. So this is going to be extremely simple. It's just going to be 1/4 times 12, which is 3, plus negative 6, which equals negative 3. So now I know that the values in between negative 1 and 0 are negative. So now determining the relative extrema from here is fairly simple. All we have to do is analyze the data that we've collected. So the points before negative 1 are positive, which means that the function should be doing something in terms of going up like this. And then after negative 1 it starts to go down. So I know that at negative 1 there is a relative maximum. And at 0, before 0, the function is decreasing and then it starts to go up. So I know that at 0 there's a relative minimum. So now what I have to do is I have to write down these points, right? So I have negative 1 and I have 0. And I know that negative 1 is the maximum and 0 is the minimum. So now to find the y value for these points, I need to plug them into the original equation, which is this one. So I'm going to do that really quickly, and I'm going to get that 4 times negative 1 cubed plus 6 times negative 1 squared plus 1 is equal to negative 4 plus 6 plus 1, which is just, plus 1, which is then equal to 3. So I know that my maximum is negative 1 comma 3. Then for my minimum, I'm going to plug in a 0, which will just cancel with these, and I'm going to be left with 1. So my minimum is 0 comma 1. And these are my final answers.